Okay. So in the last class, we have seen the concept of sign and number system, right? So earlier classes we have seen how to perform addition of two numbers in unsigned number system, right? So in the last class especially we have seen the concept of signed number system means whatever the number that you are trying to give, the number is having some sign. Like if you are going to have sign magnitude representation where most significant bit having some sign, right? The sign, like if you are going to have 1, it means it is -1. If you are going to have 0, I can consider it as plus sign, right? This is not -1, this is simply minus. Okay, and we can also represent the sign in numbers in the form of 1's complement, or we can able to represent in the form of 2's complement. Basically, all kind of systems are going to store negative numbers in the form of either 1's complement or 2's complement. But when you go for some kind of competitive examinations, there they are going to generalize the questions. Like it will in the form of b minus 1's complement, or we can say that it is b's complement, right? If you are going to work with binary number system, there can be two possibilities. One is 1's complement, another one is 2's complement, right? If you are going to have decimal number system, we are going to have two possibilities. One is 9's complement, another one is 10's complement. This is what we have seen. And also we have taken the numbers, something like, for example, I am trying to take two numbers. One is plus 45, another one is plus 62. How we are going to perform addition of these two numbers? First, what is the result of these two? Assume that they are in base 10, right? If they are not in base 10, can I assume that they are in base 7? Can I assume or not? Yes, because they are going to be valid. So they have given specifically they are in base 10, so they are also valid. Now what is the result of this one? Plus 107 base 10. 107 base 10, right? So in unsigned number system, what you are going to basically do? You are going to simply take 45 and convert it into binary number. What is the binary number of 45? 32 and 16. 32 and 16 is 48, which is greater than 45. So I can take it as 0. And then I can consider it as 1, that is 8. 32 and 8 is 40. And then 4, 44 and 0, 1. This is the binary number of 45. And if you take 62, I think 32 and 18, 40, 48. Okay, 48 plus 4, 52, 52, and I think any mistake is there. So 32 plus 16 is 48. 48 plus 8 is 56. 56 plus 4 is 60. 60 plus 2 is 62, followed by 0, which means total number is 62, right? If you are going to add these two numbers, what is the result you are going to get? 101, 1, 1, 1 is 10. What is triple 1? 1 plus 1 is 10, plus 1 is 1, 1. Double 1 is 10, 10, right? So what is the total number? Last is 1, 1. Okay, 1, 1. Right? What is the total number? This, it is equal to 1, 2, 4, 8, 16, 32, 64. 64 plus 32 and so on. If you are going to calculate, you are going to get 107 base 10. 107 base 10. Right? Here I will raise one question for you. Try to observe, if it is in 6-bit system. If it is in 6-bit system, how much memory is available for me? 6 bits. What is the result I got? 7 bits. Meaning that, is there any position to save this number 1? No. At the time, what is the result you are going to get? You are going to get minus 64, you are going to get something around 43, which is incorrect result, right? So there is no problem here in normal binary operating system. Binary system. So right now we can consider as 107 base 10. Okay. Try to observe one more point. I am trying to take two numbers. One is 45 base 10, another one is 62 base 10. I am trying to perform difference. Now, how we are going to perform the calculation? So you are going to do with first ninth complement, or you can do it with tenth complement. You can do that, right? This is what you have seen in earlier class also. 45 is basically 101101. 62 is basically component, like complement. Complement of 962 is okay. Fine. You can follow any of the procedure, right? So I think we have seen this particular procedure. 45 base 10, and you are trying to find out the ninth complement of 62. That is 37. You are going to get sum, right? 5 plus 7 is 12, 4 plus 3 is 7, so total you are going to get 82. 82, right? So 82 is what? X minus y. X minus y, right? You need to get the result of what? 17. How we are going to get it? By using once again 9's complement. 99, then you are going to get 17. This is minus 17 because you are trying to find out the complement. That is minus of x minus 1 is 17. So x minus 1 is 17. Minus 17. X minus y is minus 7. This is what you have seen in the earlier class, right? If it is in ninth complement. What about if it is in tenth complement? 45 base 10. This is 38, right? Ninth complement plus 1, 38. So you are going to get again 83. 83. And from 99 you are going to subtract. You are going to get minus 70. Minus 70, right? Fine. Take out the case for 62, 45 base 10, where I am trying to perform some kind of subtraction. Again you need to have the value called 12 7, and you need to have the positive 17, right? How we are going to do that? 62 base 10, complement of 45 is 54. You are going to do that plus 6, you are going to get 116. As you are trying to get overflow, or I can call it as carry, you are going to simply add that as here 17 base 10. 17 base 10, right? Assume that it is 10's complement. If it is 10's complement, what will happen? 62 and 55, you are going to get 117. You are going to simply discard this carry, right? This is what we have seen in the earlier class, right? Fine. The same thing what you are observing, 45 base 10 plus 62 base 10, what is the result you are getting? Plus 107 base 10, right? So you are not a, you not only can do with help of the respect to number system, you can able to finally convert it into binary number system. See, finally your system is able to understand the misunderstood format, that is binary number system, right? We can able to do that also, right? Try to observe. I am trying to do it in 2's complement. Can I do it the number 45 in 2's complement? What is the advantage of 2's complement? I can able to store either positive numbers or negative numbers, right? If it is going to start with 0, what is the meaning of this one? In 2's complement, number is positive. In 2's complement, one represents negative. So I can represent both positive numbers as well as negative numbers in 2's complement or 1's complement also, right? So what is the value of 45 in 2's complement? Right? What you can do simply, first try to write the binary number of 45, try to perform 1's complement, then try to add plus 1, plus 1. Or what is another solution? I have given one formula, minus 2 power n plus 2 power n minus 1 plus 2 power n minus 2 and so on 2 power 0, right? So you can directly understood that this is positive number. I can write as 0. It is 0. And 32, you should not write 16, 32 and 8, 40, 44, 0, 1. This is 2's complement of the number 45. Is it okay? Try to think. If you want, you can understood, right? This is see, this class is very very important for you. 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. What is the formula for this one? Minus 2 power 6, right? What is minus 0 into minus 2 power 6? 0 only, 0 only, and you are going to sum up all this 32 plus 8 plus 4 plus 1, you are going to get obviously plus 45, right? So if you want, you can do like this. What is the basic binary number of 45? The same only, but the thing is you are going to get less number of bits. 101101 is also equivalent to 45, right? But the thing is, here you have to make it complement once again. What is the complement of this one? This is 45. What is complement of this? 010010. For this you are going to add plus 1, right? If you are going to add plus 1, 010011, this is what? Minus 45, not plus 45. Minus 45, right? Okay, you can just calculate it. Ma? Okay, fine. Try to think this one. This is plus 45 in 2's complement. What about this plus 62 in 2's complement? 0. All ones, I think this one. Or some other. See, once the concept is completed, you will get the idea. Don't worry. What is the addition this one? 1, 1, 1, 0, 1, 1, 1, 0, 1, 1. You are going to get 1. What is this total value? You are going to get around negative number. Why I am saying it is negative number? Because at the end you got the 1, right? So try to calculate fast, right? This is minus 2 power 6, means minus 64 plus 32, 8, 2, 1. Calculate this one. 43, if you are going to remove, total you are going to get as minus 21. But what is the result you have to get? What is the result you have to get? Plus 107. So here try to think, I am simply adding 1 0. I am simply adding 1 0. Now try to calculate. If you try to calculate plus 0, 0, are you going to get the plus 107? Yes, you are going to get. Okay, fine. So for timing, try to think this one. And take out the one more number. 45 base 10, 62 base 10. I am trying to perform subtraction. So what is 2's complement of 45? 0 1 0 1 1 0 1 1 1 0 1, and 62 2's complement. 62 2's complement is what? 0 4 ones 5 1 0. 0 5 1 0 is what once again? Is it negative 62? No, it is plus 62. You have to have minus 62. What is minus 62 here? See, if you want to get minus 62, can I add 1 here? See, you have to calculate more. Without calculation, you can't get. Right? How we are going to get minus 60? See, try to calculate 62. 62 is so this is 62. Can I say this is 62? 0 5 ones followed by 0. For this, if you are trying to calculate 5 zeros, 1 1. For this, we are going to add plus 1. You are going to get 1 triple 0 0 1 0 is the complement of 62, meaning that minus 62. Right? Try to add 1 0 0 0, 0, 1, 0. Now try to add. What you are going to get? 1, 1, 1, 1, 0, 1, 1. Right? What is the value you are going to get again? Right? This is minus 62 and plus 32 plus 8 plus 4 plus 3 plus 2 plus 1. Try to calculate 40, 47. If you remove the 47 from 62, what is the value? This is 64, huh? Right? What is the result you are going to get? Minus 17. Minus 17. So is this result we are expecting or not? In this particular situation, is this result we are expecting or not? Because 45 minus 62 is 17 base 10. That is minus. Are you getting the result? Yes. Here in this particular situation, you are getting the result. So there is no problem here. Right? So try to think one more situation. I mean, you can able to do this processor also. 62 base 10, 45 base 10. I am trying to perform subtraction. What you can do? What is the value of 62 in 2's complement? 0, 5 ones, 0. So this you have here. What is 45 in 2's complement? So I think this is only for 45 in 2's complement. This is 45 only. For this we are going to complement it. See, 0, 1, 0, double 1, 0, 1. For this if you are going to make complement 1, 0, 1, double 0, 1, 0. If you are going to add plus 1, you will get like this. Right? Try to do this 1, 0, 1, double 0, double 1. Try to calculate 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 0. What is the value you got here? The result is in 2's complement. When the result is in 2's complement, what you have to do? What is this value? 1 represents minus. So are you getting the minus or not? Yes. But try to calculate. This is now minus 128. Minus 128. And then this is 16. 16. And this is 1. So if you remove 17 from 128, you are going to get minus 1, 1, triple 1. 1, 2, 4, 8, 16. Anywhere we did mistake? Ma? So what is the result you need to get here? See, this is minus triple 1, right? This is minus triple 1 base 10. This is okay. But if you observe here, this one represents what? 16. This one represents what? 1. 16 plus 1 is what? 17. What is the meaning of this one? Here you can simply avoid this consideration. So that are we getting 17 base 10 or not? 17 base 10. Right? Try to think one more case. Minus 62 minus 45. What is minus 62? I think this one. 1, 4 zeros followed by 1 0. This one is minus 62. Minus 45 is this one. 1, 0, 1, double 0, double 1. Try to calculate 1, 1 0, 1, 0, 1, 0, 1 0. So what is the result you need to get here? So if you are able to calculate, you will get the answer. That is minus 128 plus 16, 16 plus 4, 20, 20 plus 1 is 21. If you are going to remove this one, you are going to get minus 107. Minus 107, right? So meaning that Is our result is getting or not? Minus 107. But here the question is, sometimes we are going to consider this overflow, and sometimes we are eradicating this overflow. Sometimes we are going to add this 0. Sometimes we are not going to add anything, right? That is our question. So why it is happening? So it should not happen, right? As a human being, we can able to understand. But what about the system? System can't able to think right like this. So we have to make some procedure where you have to generalize everything. If you are going to give any kind of input, it has to process it. That is our requirement, right? So take out one more number. For example, i'm trying to give I'm trying to give the numbers like -8 and -4. -8 -4. What is the result you need to get? -12. What is the 2's complement of -8 in 2's complement number? 1 triple 0, right? -2 cube plus 0, 1 triple 0. Okay. What is 2's complement of -4? 1 1 double 0, right? So if anybody not understood, try to observe. This is -8. It is +4. Total you are going to get as -4 only. Okay, na? See why I am getting this -4. -2 power n plus 2 power n minus 1, so on. I try to add now 0 0 1 1 0. What is the center value? -12 only. Why? Because this is -16 and this is +4. Total is 12. But here thing is we are trying to consider the extra bit 1. If you are not going to consider extra bit 1, it will be +4 only. But we need to be in a situation where we have to tell to the system that you have to consider this overflow also, right? For that, what you have to do? See, if you are not going to consider this overflow, what is the result you are going to get? You are going to get +4, which is definitely wrong answer. Wrong answer, right? So meaning that, so at what situation you are going to get the correct result? When you are trying to give the system to the 4-bit number, system is going to give memory space for the result also 4-bit number. But we need to tell to the system in a position that please try to add one more bit so that result will be correct. Right? So we need to identify a situation where overflow is happening. What is the meaning of overflow? So it requires extra bits to store the data. Then the system will get the actual data, right? So if you are going to have only 4 bits, it is not sufficient to store the data. That is why you are getting the incorrect result. So if you are going to tell to the system that there exists a overflow, so please add one more memory location. So this one won't be lost. When one won't be lost, your result will be -12, right? So try to think, when you are going to add two negative numbers, what is the result you are getting? Basically, in terms of system, a positive number you are getting, right? So don't worry about this one, because in terms of system memory, if you consider there is only 4 bits of memory space. So when you are trying to add two negative numbers, you are getting the result as positive. At that time, you can consider it as overflow occurred. So this is one condition where you can inform the system, so that system will allocate one more extra space. Or you can say in other terminology, there exists a carry. When you are trying to add two negative numbers, if carry generates, there exists a overflow. So try to think one more situation. For example, -6 plus 6. What is the result you have to get? 0. What is the 2's complement of -6? Right? So if you are unable to calculate it, try to 0 1 1 0, and complement is 1 0 0 1, 1 0 0 1 plus 1. So what is directly you can tell? 1 1 0 1 0. Very good. 1 0 1 0, right? This is minus 8 plus 2 minus 6 only. What about plus 6? 0 double 1 0. You are going to get 0 1 0 1 0 1 0. What is our result? We need to get 0, right? So at this situation, if you are not going to consider this carry, what you are going to get? Are you going to get the result or not? Yes, right? So at this particular point of time, you should not consider the carry. Meaning that, can I say that you have to indicate that there is no overflow to the system. When you are saying that there is no overflow, system is not going to allocate extra memory so that our result is correct. So when you are trying to add one negative number and one positive number, even carry generated, you can say that there is no overflow. Why there is no overflow? If I am going to give that indication, the system will think that you should not allocate extra memory space. When you are not allocating extra memory space, this one automatically discarded because there is no enough memory space is there, right? So that is the reason. Right? Try to take one more example. For example, I am trying to take two numbers, plus 7 and some other number like plus 9. Plus 9. What is plus 7 in 2's complement? 0 triple 1. Okay, and plus 9 is 1 double 0 1. Try to think, this is 1 0 1 0 1 0 1 0 1 0. What is the value you need to have here? 16, right? So if you consider total, is it a 16 or not? Yes, meaning that here there exists a overflow, meaning that you have to consider that extra bit also. If you are going to consider extra bit, you will get the result. So then what you can tell to the compiler, when you are trying to add two positive numbers, see, I am trying to think about worst case. When you are trying to add two positive numbers, if there exists a carry, you have to tell to the system that there is a overflow, meaning that it is going to allocate extra memory space so that you are going to get store that number 1 or number 0. See here, I am getting certain question. What is 1 followed by 4 zeros? It is minus 16, right? It is minus 16, I think. Am I right? But what is required? You require plus 16, right? So can you cross check once? 7 is 0. See here, I have written 9 is what? Is it 9 or minus 8? Sorry, minus 7. Minus 7. That's the reason we got the wrong result, right? So if you have to make it as 9, what you have to do? This is 0, so I can make this as also 0. Why you are all silent? So now your result will be correct. Try to think 1 1, sorry, 1 0 1 0 1 0 1 0 1. So 1 followed by 4 zeros, 1 followed by 4 zeros, you are going to get the 16, right? There is no carry generated. There is no carry generated. When there is no carry generated, you no need to bother about it. No need to bother about it. But we have to think in situation that at the worst case, if there is a carry generation, for example, plus 9 followed by plus 9, plus 9 followed by plus 9. What you are going to get? Now also, I think now you required 18, right? Right, think 0 1 double 0 1, no problem. 0 1 double 0 1. So we are going to get 1 0 1 0. So this is 1 0 1 double 0 1 0. Right? Now think. Now point here is you got the result as 1 double 0 1 0. 1 double 0 1 0. What is the meaning of this one? In 2's complement. This is minus 16. This is plus 2. That is minus 14. Right? Is it the correct one? No. At this time, what you have to tell to the compiler? You have to add 1 0. You have to add 1 0. If you are going to add 1 0, this will be plus 16, this will be plus 2. So your result will be plus 18. The same case here also. When you are going to have this number, it is minus 16, not plus 16. So you can tell to the compiler that 0, then it is plus 16 only, right? Meaning that when you are trying to add, two positive numbers, when there is no carry or when there is a carry, you have to tell to the compiler that there is a overflow. When you are trying to say that it is a overflow, what the system will do, it will add extra memory space, so that by default it will get 0. 0 means by default it will get as a positive number. Okay, fine. So these are the three cases that you have to remember, right? So you can, if you want, you can just apply the same case for the earlier examples also, right? Try to think, when I am trying to add two numbers, so I think these two numbers are what? 2's complement, right? These two numbers are 2's complement. In 2's complement, if you are going to add two positive numbers, you are going to get carry or may not get carry. You have to add it as a overflow. So that means you have to generate 1 0. So that's the reason you got plus 1 0 10, 1 0 7 base 10, right? So when you are trying to perform one positive and one negative, what is the rule I have defined? When there is a carry, you have to say that there is no overflow, meaning that the extra generated bit should be discarded. Right here, you are trying to add plus 45 and minus 65, minus 62. There is no carry, so you have to go with the normal procedure. Here you have to think minus 1, minus 62 and minus 45. Here you are trying to consider one extra generation that should be considered, because I am saying that is overflow. Then only you will get the result, right? So if you follow these three rules, you will get the correct results. Okay, now, so think about this one. So means here, when you are trying to solve any particular kind of these problems, you are trying to check always whether the first number is negative number or not first, and second number is negative number or not, and in the result also you are trying to check whether the number is negative or not. Meaning that total you are trying to check for three comparisons for to get the result. So in order to define whether there exists overflow or not. Okay, now see, finally what you have to tell to the system, whether you need to append one extra bit of memory or not. In order to append extra bit of memory, you have to always think about these memory locations. First number is negative, second number is positive, or negative negative, or positive negative, positive positive. Followed with the result, you have to compare. Meaning that three comparisons are required. Instead of this, what we can do now, we can simply take one analogy. I am trying to take four digit number A1, A2, A3 and A4, B1, B2, B3 and B4. If I am trying to add these two, right, both are from the 2's complement numbers. So the simple logic is, when you are trying to perform the addition of A3 and B3, if it is going to generate some carry, I can call it as carry in. So that carry in will be added to what? A4 plus B4, and it is going to produce some result, right? That result can contains carry out also. C out means carry out. So with this conclusion, I can able to define, when C in is equal to C out, I can able to define one as overflow occurred or not, or when both are not equal, I can define overflow or not. Try to take out this example. This example. I am trying to add two negative numbers. This is okay. Here, when I am trying to add the last two numbers, 0 and 1, I am going to get 1. Is there any carry in provided? No. Means it is 0. And when I am trying to add 0 plus 1 plus 1, What you are getting? One carry, that is 1. That is 1, right? So carry out is 1, carry in is what? 0. 0. When carry out is 1, carry in is 0. What is the meaning of this one? Overflow occurred. So simply that logic can apply, right? When carry in and carry out not occurred, so there exists overflow. And whereas coming to this one, no overflow. No overflow. So now you can able to reduce the hardware performance. I mean processing, because in the earlier things you required three comparisons whether overflow or occurred or not. One is first number is negative number or not positive number, second one is negative number or positive number, and the result is negative number or positive number. You have to check. So based upon these three conditions only you are going to define overflow occurred or not. But in this particular case you are going to simply define checking of these two parameters. First one condition is if this is one condition and second condition is this. With help of these two conditions I can define overflow occurred or not. So that is the advantage of this one. Okay, na? Fine. So I hope you understood everything clearly, right? Here. Is it okay? How we are going to do? Okay. So coming to the next concept, we'll go with further. As systems are trying to store your data entirely in the form of binary format. So in binary number system also, it is going to approach, it is going to follow various kind of other systems. So something like if you elaborate it, if you try to take binary codes, these are follows various kind of approaches. One is alphanumeric approach, or numeric approach also. Right? Alphanumeric approach means this is the binary code system where you can able to store the data either of alphabets, numbers, special symbols, or whatever it may be. Whereas coming to numerical approach, we can able to work with only numbers. We are trying to convert numbers into binary system. That's it. Whereas coming to here, alphabets also converted into number system. Right? So the simple examples for alphanumeric binary codes is ASCII, American Standard Code for Information Interchange. Like capital A ASCII value is something and small a, right? So that is example. One is Unicode. Like this, we are going to have various kind of number system, binary code systems are there. Coming to alphanumeric system. Whereas coming to numerical binary codes, basically it is going to store in one kind of approach that will comes under BCD approach, binary coded decimal approach. Binary coded decimal approach, also call it as 8421 approach. 8421 approach, right? Or some kind of 3321 approach, 21 approach, or we can take some other, like this. We are going to have various kind of approaches. These I can call it as weighted code sum. Weighted codes. So let me tell why I am calling it as weighted codes. Okay. First I will tell the classification. In another kind of classification, they will be classified as non-weighted codes. In non-weighted codes, we are going to have one kind of codes are gray codes, another kind of codes are Excess-3 code. Gray code and Excess-3 code. Right. So here you can take 6-3 1 minus 1 is also one kind of representation, and something like 2-4-2-1 is also one kind of representation. I mean, if you take the numerical binary codes in the system can able to store in various kind of different approaches. Among this, one kind of approach is 2-4-2-1 system code, or 6-3 1 minus 1 approach, or BCD approach, or 3-3-2-1 approach. Like this, it can be able to follow. Right? Simple thing. If you would like to write a letter in the system, how we are going to write the letter? You can able to write all in small letters, you can able to write all in capital letters, you can able to write all in capital letters, combination of letters. like that. Based upon the requirement, you can able to follow various kind of approaches, right? So first I will go through what do you mean by 8421 approach, right? If you take 8421 approach, this 8421 approach meaning that your decimal numbers are trying to store in which format? Binary system, right? In that binary system, one type of format is 8421, right? So what kind of numbers you can able to store? Decimal numbers, decimal numbers, right? So try to think. This 8421 approach can able to have the pattern numbers from 0 to 9 number, 0 to 9, right? How we are going to get the 0? By making all numbers as 0, by making 0001, 0010, 0011, 0100, 0101, 0110, 111, right? Fine. This is the basic thing what we are going to follow in 8421 approach, right? Guys, if somebody asking you to represent the number 12 in 8421 system, is it possible to store the 8421 in sorry 12 in 8421 system? No, because its pattern is ranging from 0 to 9. You cannot able to represent other than this, right? But what is the another way to represent this 12? So for 2 I can represent in the form of 0010, right? Meaning that each and every digit I can able to store in the form of 4 bits in 8421 approach, right? What about 10001? This represents 1, this represents 2, right? In 8421 approach, if I am going to have 4 decimal digits, how many bits are required? 16 bits are required, because each digit requires 4 bits, 4 bits, right? And this kind of pattern I can call it as sequential approach mode. Sequential coding system అని కూడా పిలవచ్చు. We can call it as sequential coding system, because if you know one number, if you know one number, if you are going to add +1 to the existing number, you will get the next pattern, right? If you know 0, if I am going to add +1, I will get next number. If I add +1, I will get next number, and so on, right? Sequential means what? 1 followed by 1. And the next kind of approach is, let me come with the Excess-3 code first. Excess-3 code, right? This is one kind of pattern where you are going to store binary numbers. Okay, fine. So Excess-3 means what? Whatever the number that you are trying to store, instead of that number, you will simply add +3 to that number and you will store, right? If you would like to store 0 in the system, what you are going to store? We are going to simply add +3. +3 means what? 0011. 0 means 0011 in Excess-3 system, right? What about 1? 0100. Now understood, right? Right? 2 means 0110. 0111. Why you got 0111? 4 plus 3 is 7. Excess-3 means existing decimal system will be added with +3. So 5 means, right? So I can directly write 7 plus 3 is 10, 8 plus 3 is 11, and I think this one is 1100. Is it okay for everyone? Yes, right? So 9 plus 3, you are going to get 12. So what is the range of Excess-3 code system? 0 to 9 only. The range of Excess-3 code system also from 0 to 9, but the way they are storing is different. The way they are going to store is different, right? If somebody is asking you to, for example, 00, 11, 0111, 1101, and 1011, Which of the following is not Excess-3 code? What is your answer? 1101. Because in Excess-3 code system, what number is not possible? 13 is not possible. Up to 12 only it is possible. So this is the correct answer. Right? And one more thing, can I call this as a sequential system? Yes or no? If you are going to add +1 to the existing system, you are going to generate next number. So sequential system I can call, and I can call it as one more important one, self-complementary system. Self-complementary system. What is the meaning of self-complementary system? Means if you take here, 0 and 9. Observe 0 and 9. They are complement to each other. Ones complement to each other. 0011. If I am going to have ones complement, what you are going to get? 1100. Right? That's the reason I can call it as complement to each other. But the condition is, if you are going to take a decimal number, there is one more condition you have to follow. If to say the number is self-complementary system, when you are going to consider decimal number, for this decimal number, you have to find out the ninth complement first. What is the ninth complement of 0? 9. 9. This number I can directly write one's complement of 0. One's complement of 0. Then I can call it as self-complement. For example, I know 4 value in Excess-3 system. As I know Excess-3 system is a self-complementary system, first what I will do, so you don't know the meaning of this one, try to think. I will simply follow, as it is self-complementary system, first I will try to find out the ninth complement of 4. What is the ninth complement of 4? 5. Right? As I find out the ninth complement of 4, it is 5. Its value is what? One's complement of 4. What is one's complement of 4? 1000. I think this is the value only earlier exists. Right? This is what I can call as self-complementary system. Try to check. These two are complement. These two are complement. These two are complement, and this also complement to each other. So I can call it as self-complementary system. Okay. So if you observe, Excess-3 will comes under non-weighted code. Why it is non-weighted code? Because if you take a particular value, you cannot able to assign an individual weight to it. Whereas coming to 8421 system, if you take this particular number 1, I can assign a value as 8. If you take this particular number 1, I can assign a value as 1. Whereas coming to this particular system, I cannot able to assign like that exactly. That's why it will comes under non-weighted code. And coming to one more system, 3321. 3321 is also a kind of self-complementary system. Is also a kind of sequential system. Okay, fine. How we are going to represent the 0 in 3321 notation? Can I write like all zeros? Yes or no? So 1 00001. See, now we understood that why it is weighted code, because each and every location having some weight. And what about number 2? 0010. What about number 3? Right? So if you take here number 3, you have multiple possibilities. One is 1000, another one is 0100, another possibility is 0011. These are 3 possibilities. So among these 3, what you have to consider is the number which is having the least decimal value. What is the least decimal value? 0011. So you have to write that. Okay, fine. What about the number 4? So number 4 having the possibilities as 1001, 0101, which is having the least decimal value 0101, 0101, right? What about the number 5? Right? So you know the definition of self-complementary system, right? Simply what I can do, 1010. Can I write? Because the complement of 4 is 5, and so one's complement is 1010. So I can write like this. This one as 1100. If you want, you can just cross check. 1100. What is the value of this one? 1101. And what about this one? 1110. This one is 111. Right, guys? Here you may get confusion. Right? You are getting like not following the rules. Yes or no? Again, sir, you said like you have to take out the least decimal number system, right? You have to follow only for up to half of the numbers, and from that you have to find out its complements. Okay, fine. So this logic I have given for just for your remembrance only. Okay, fine. This is what I can call it as a double 3 2 1 system, right? So meaning that uh, if you observe here, except 8421 except 8421, all the remaining codes what I mentioned here will be comes under self complementary system. Self complementary system, it means that you can able to find out complement of one number which are below 4. Okay, and one more thing is, if you are able to add its weights, what is sum of 2421? 9. What is sum of 631 1 minus 1? 9. What is sum of 3321? 9. If a system is going to follow, if a system is going to say that self complementary system, whose sum will be 9, but not vice versa. If I am saying that it is a self complementary system, whose sum will definitely 9. Is it okay? Okay. Now try to do this example. If I am going to have a number 7 5 6 base 10, try to write in BCD format and try to write in 8421 format. Is BCD and 8421 both are same or not? Yes. Right. Conversely, I can call. So can I write like I can write Excess-3 also. You can write 3321. You can write it for binary number system. So tell me, what is the answer for BCD of 756? So for 7, what is the value? So each and every digit requires 4 bits. Very good. 0, 111, 0, 101, 0, 110. This is BCD of 756, right? What about Excess-3 of 756? 1010, because 7 plus 3 is 10, and this number is 5 plus 3 is 8, meaning that 1000. 6 means 1001. In 3321 notation, 7 means there is no possibility, you need to have 3301. I mean 1101. Compulsory there is no option. What about number 5? You have two possibilities. But the thing is, when it is beyond number 4, what you have to do? You have to find first. You need 5, right? 5 complement is 4. What is the value of 4? 0101. Further complement is 1010, or you can observe here 1010. What is 6 value? 1100, which I mentioned here. I have written. Okay, fine. If you take it binary number system, basic system, you have to divide it with 2, right? What is the value? What is the value you can do? right? 2 means double zero, 1 0, all ones. So you got this result. Is it okay for everyone? Or any mistake is there? Right? Don't worry about the first two zeros. Yes, right? So if you observe now, right? So in one kind of system, I mean in any, if you take any system, hardware system, the same 756, I can able to represent it in multiple way of notations. I hope you understood with this one, right? Binary code variations. One in BCD, see, BCD is completely different from binary number system. You should not confuse with this, right? Results also completely different. So with this example, I can say that all these systems are completely different from one among each other. Okay. So I think we did with the weighted codes, and Excess-3 also we did, right? So same way, if you take 2421, 2421, how we are going to write 0, 4 zeros, how we are going to write 1, 0001, and how we are going to write 2, 0010, how we are going to write 3, 0011, right? Like that you have to do, right? Until 4 you have to do. Next remaining thing you have to find out the complementary of the system. Because I said it is already equal to 9, so it is self complementary. Okay. So next kind of binary notation is gray code. This is very important. Gray code. See, if I am going to have a number in gray code notation, system will store, right? Basically, you are going to have numbers from 0 to 9 only. Okay, I will write once again. Or whatever, any number of numbers may be there, I can represent. See, the thing is, when the basic properties of gray code are, first important property is it is reflexive. Gray code system is reflexive system, and which is Unicode system, and it is following a property called cyclic property, and then I cannot call it as sequential system because you are not going to get the values. I can call it as unweighted coded system. Unweighted code, right? Unweighted or non-weighted code system, because it is comes under non-weighted only, because you cannot able to assign the values to the each and every particular location, right? Guys, if you observe, if I am going to have one number, one digit only, what is the, if I am going to place this number in the mirror, opposite to the mirror, what is the value of this one? 0 only. If I am going to have only one bit, 1, mirror number is 1 also, 1 only. Am I right or not? But if you take two numbers, two numbers in a system log 0 and 1, if I take 0, take 0, whose mirror is 1, for basic one system, right? You have to think. For example, if I take 2 bits, if I take 2 bits like 0 and let me take as, I am trying to take it as a mirror. Try to think, if I am going to have 0 1, what is the mirror of this 0 1? Can I call 1 0? Yes, right? So I can call this as a mirror. This as a mirror. So try to put two numbers 0 like this. So don't think about the first portion. Just compare only the second level of bits. This is what I can call it as mirror. So I can call it as reflexive. Try to extend this one to 3-bit system. What is going to happen? If this is mirror, this is mirror. Here what you are going to get? 1 0. Here we are going to get 1 1. Here we are going to get 0 1, 0 0. Is it okay? Now try to add the whole like above all are zeros and below all are ones, right? Is it a mirroring or not? Yes, right. So try to think. I'm going to write the same thing here. See, I have written something like this: double zero zero one, double zero zero one is, so for this 10, what is the mirror? 10. I put just 1 1 here, right? For this entire thing, I made one mirror: 10 11 01 01. Sorry, 00 00. Right? Now try to add number of zeros and here number of ones. So it is simply like look like a mirror. So I can call it as it is satisfying the property called reflexive property. Reflexive property. If you want to extend, what you can do? You can simply make this as a mirror and add above zeros, add bottom ones with reflexive property. Okay, fine. See how we are getting this one. So you should not, like, for example, in the question, if they give like what is the gray code of 456, you cannot able to write like this values, right? So try to think what is the actual value of 110. So I mean 4 in normal binary system. What is the value? 100. 100. Okay, fine. So now try to think how I am getting the 110 means I am going to write the one as it is, and I am trying to perform XR operation over the earlier number and the present number. One XR with 0 is what? 1. XR operation. When both are different, result is 1. When both are same, result is 0. 1. What about the next number? 0 XR with 0. 0. Are you going to get the number or not? Right? Try to take out the value of 2. 2 value is what? 0 1 0. Try to perform XR operation. How we are going to do this? 0 should be 0 as it is, and 0 should be XR with 1, that is 1. 1 XR with 0 1. 0 double 1 is 0 double 1. You got or not? This is the way you can able to convert binary to gray code, meaning that if you know binary code, you can simply convert it into gray code by making use of XR operation, right? Meaning that if you are going to have multiple numbers A1, A2, A3 and A4, or you can just simply make opposite: A4, A3, A2 and A1. If you want to get the gray code, first simply add A4 as it is. A4 as it is. A3 how we are going to get? Sorry, B3. Next number how we are going to get? A4 XR with A3. Next number is A3 XR with A2. Next number is A2 XR with A1. XR with A1, right? In simple terms, if you would like to say, if you would like to find out the next number, Bn, what you are trying to do? You are trying to perform An plus 1 XR with Am. Is this equation is correct? Yes or no? Right? This is where it will be helpful for you. If I am trying to find out like B3, try to substitute. If I am trying to find out the B3, how we are going to get to B3? A4 plus A3. So try to substitute. Here n means 3 plus 1. That is A4 plus A4 XR with A3. Is it okay? Yes. So this way you can able to do. Okay, fine. Similarly, if I am going to have an XR number, if I am going to have like gray code, can we able to get gray binary code? We can do that. Try to observe. If I want to get the number, I am going to simply right. So you can simply get the value of the most significant bit 1 as it is, 1 as it is, and try to perform XOR operation of the previous result with the current bit. What is 1 XOR with 1? 0. The result of previous bit should be XOR with the current bit. 0 XOR with 0 is 0, right? 100. Are you going to get 100 or not? So this is the procedure you have to follow. See, observe 011. So you have to write the as usual procedure 0. You have to perform XOR with 1. 0 XOR with 1 is 1. 1 XOR with 1, 0. So 010 you got. Right? This is the procedure you have to follow while converting gray code to binary code. Gray code to binary code. Right? Indirectly I am trying to say that if I would like to find out the A1, if you would like to find out the A1, what you are trying to do? I am trying to simply perform XOR operation of all the things. an minus 1, an minus 2, and so on, a2. If you want to find out the a1 value, I am simply finding the XOR operation of all the things. Okay, now this way. If you want to find out the XOR of, if you want to find out the value of a2, what you have to do? I need to perform the XOR operation of an to a3. Is it correct? Is it correct or not? Try to check. See, if you want to find, if you want to know the value of this 0, the value of this 0, what I am trying to do? I am trying to perform XOR operation of this value, this value with this value and this value, right? What is this 0? Earlier value. What is this value? Actual existing value. Indirectly I am trying to say that I am trying to perform the XOR operation of all the values. Okay. See, why I am trying to do all the things means, so this analysis is required when you are trying to construct circuits. Like for example, if you analyze something like this, assume this is a circuit board. Circuit board. For this circuit board, I have given 4 inputs. What are those inputs? For example, let me take A1, A2, and A3 are the inputs I have given, right? So for this, what is my so like assume that this is a kind of circuit which is meant for to convert binary code to gray code. What is A3? A3 should be directly written or not? A3 should be directly written. So A3 will be directly connected to the output B3. B3. How we are going to get B2? B2 you are going to get XOR operation of A3 and A2, right? So I am going to take the input of A2 and input of A3. You can, so there is a symbol called XOR operation symbol, which is going to produce B2. Produce B2, right? How we are going to get B1 here? XOR operation of A1 and A2. So like this, you need to draw the circuits in the future. So that is where you are required this kind of analyzation, right? See, now try to observe, try to analyze. If I am going to give the input like I am trying to take some number triple one, triple one. If I am going to give one here, if I am going to give one here, that one will be occurred here and one also will be occurred here. A2 will be here. What is XOR operation of 1 and 1? 0. B1 output is 0. What is the here 1? Here also 1. What is 1 XOR with 1? 0. What is A3? Is there any processing done here? No, directly copying, right? This is 1. So meaning that if I am trying to perform binary code triple one, what is respect to gray code? 1 0 0. Are we going to get 1 0 0 or not? Yes. So like this, the system should have to capable system have to solve, right? As a human being, we are going to work on paper, but for the system, it can able to do it with help of circuits, right? This is why you need to learn all the things. Okay, fine. Here I said like it is reflexive. Okay, and why I'm calling it as Unicode means if you observe any two systems which are immediate to this one, how many bits are changing? Only one bit is changing, that is only 0 and 1. If you observe these two, how many bits are changing? Only one. If you observe these two, how many bits are changing? Only one. If you observe these two, how many bits are changing? Only one. This is what Unicode system, meaning that at any point of time, if you take two adjacent numbers, only one bit is going to be changed. Only one bit is going to change. That is what I can call it as Unicode system. Even even if you take the corner numbers, one, sorry, 7 and 0, only one number is going to be changed. 100, only one, only 000. Right? This is why I am calling it as cyclic code also. Cyclic code, right? Meaning that if I am going to give the number, if I take the numbers from 0 to 7, if I are going to generate the processing, always it is going to get the numbers from 0 to 7. Simply nothing but modulus 7. What is the meaning of modulus 8? Modulus 8 at modulus 7. Modulus 8, what are the range of values we are going to get if you give n value as numerator? 0 to 7, right? So that is the only. From 0 to 7, you are going to get always the values, right? Cyclic code. Next, this one is unweighted code, which you know. Okay, fine. So this is what about the concept of gray code summary, right? So if you observe, right, as we are going to have various kind of number systems, number formats of saving the data, right? We have performed various kind of operations like addition, subtraction operations over the binary number system, which is normal number systems. But if you take BCD addition, if you take BCD addition, what is going to happen is BCD addition and binary number system addition both are same. Is it both same? No, because if you observe here, if you observe this example, this BCD contains the value, this is value, and in binary number system value this, right? When both numbers are completely different, the result is going to be different, same. No, different result is also going to be different. Right? Meaning that, see, even when you are trying to work with binary number system or when you are trying to work with BCD system, the result should be same. I don't bother about anything what the system is going to follow approach, but my result should be same, right? That is the thing you have to find. So in binary system we are going to follow one approach. In BCD addition we are going to follow one kind of approach. If you take the numbers like 7 and 4, 7 and 4, what is the value of 7 in BCD? 0, 111. In BCD 4, BCD means 8421 only more, right? What is the value of this one? 110101. What is the value this? 11. This is our understandability. But what about BCD system? In BCD system, at least is this pattern exist? No. Every 4 digits will be considered as one digit, right? Then it is not valid, right? Meaning that it is invalid. It is invalid, right? So, but what is the result we need to have? 11. Right? Can you able to convert this 11 into the binary coded decimal number system 11? So binary coded number system 11 means what you are going to get? 0001, 0001. So can you able to convert this to this? No, it is not possible. You have to make some kind of processing. Try to think, right? So I am going to simply add plus 6 to this one. As it is invalid, I am going to simply add plus 6. What is that plus 6 means? 0, 0, sorry, 0, 1, 0, 1, 1, 0. Try to add now. if you are going to add, are you going to get 1? 1 1 is 1 0, 1 1 is 1 0, 1 1 is 1 0, carry is 1, means it is here, right? So in BCD addition, how many bits are considered as 1 bit? 4. So okay, and how many bits are considered as 1 bit? So here you can simply add 000, right? Is these two are same or not? Meaning that what you have to do, so when you are going to get invalid data, invalid patterns in BCD addition, you have to simply add +6. Why you have to add simply +6 only? If you are going to have the ranges from 0 to 9, and what are the other possible numbers possible? 10 to 15. 10 to 15, how many values are there? 6 values. If I am going to add +6, what is going to happen? Again my values comes into again this range. That's the reason they are going to add +6. They are going to add +6. Okay. Fine. Try to take one more example. Anything what you want. 9 and 9. What is 9? What you are going to get here? 1 0 1 sorry 1 0 0 1 0. Okay, 9 9 18, right? But the thing is, result is 18. Have you got the 18? How? Right? This is not 18, right? This is not 18, and this is, observe. Observe, if you take this 4 bits or if you take this 5 bits, is it invalid pattern or not? It is invalid pattern. When you got invalid pattern, what you have to do? You have to add +6. When we are going to add +6, 0 1 1 0, try to do 0 1 0 1 0 1 1 1, right? Try to take out this one. This is what? 1. This is what? 8. Have you got the data? Simple thing is, when you got invalid data, try to add +6. Okay, so this is single data. For example, I am trying to take large number 243 467. Now try to solve. How we are going to write 243 in BCD system? 00 10 0100. Is it visible, right? Yes. 0011. Right? What about 4? 0100. Okay. What? Okay. This 4 is correct, right? 6 means 0110. 7 is 0111. If you are going to add, what is going to happen? Try to think. This 1 and 1 is, I will take another color. 1 and 1 is 1 0. What is 111? 1 1. And double 1 is 1 0. And 001 is 1. Right? Is it a valid one? 1010 is valid one. 1010 is 10, which is not in our BCD representation. So what you have to do? You have to add +6. 0 110. When you add 0 110, 0 1 1 is 1 0, 1 1 is 1 0, 1 1 is 1 0. So 1 will be comes to here. Comes to here. Okay. Fine. Now try to add now. This is 1 1 1 0. I think you know, right? Is it correct? 1011. But pattern is not available. When pattern is not available, you have to make add of +6. So when you are doing this 1 1 0 1 0 1 0, so carry will comes to here. Okay, fine. Now try to think this one. what you are going to get here, this is 1 1 1 0. Is it correct? 0 triple 1 is in our pattern, right? So no need to add carry, so no need to add any plus 6, right? Now try to do this this one. This is 10, means 4 6 10 11 8 10, right? This 7, huh? 7, right? This is 7, this is 1 0. So like this. So when you are going to get the carry, so when you are going to get the invalid pattern, you have to simply add plus 6. Okay. Why we are adding the plus 6? In order to get the number into our number system, we are simply adding the plus 6. Okay. Similarly, if you go for Excess-3 addition, I will take the same numbers only, 7 and 4. What is Excess-3 of 7? Excess-3 of 7, 1 0 1 0 10, right? What is Excess-4 of Excess-3 of 4? 0 triple 1, 0 triple 1, right? Try to add, what you are going to get, 1 1 0 1 0, carry 1 0, right? Right, what is total value? 1 1 11. Is it correct? uh Is it correct? See, observe, is there any discussion of 0001 in our system? In our Excess-3 system, is there any number present at least? No. Meaning that it will come under what kind of pattern? Invalid pattern. When invalid pattern, what you have to do? Plus 6 add చేయాలా? Plus 3 add చేయాలా? So just think about it, right? The point here is when there is a carry generation, you have to simply add, plus 3 plus 3, right? What is plus 3? 0011. Try to find out. This is 1 0, this is 1 0 1 0. 0 1 0 0. What is 0 1 0 0? 4, right? 4 in Excess-3, but 1. So we need to have the result as 1, right? So we got one more 1 1 1. Okay, na? We got this one. This one represents what? 001 actually, but in BCD, in Excess-3 operation, what is the meaning of this one? 0100. This is normal BCD 8421. In our Excess-3 it is 0100. So are we getting the correct or not? One part is correct. What about here? Right? So here the point is, I will tell, right? So this is like getting confusing. Once again I will take. So what you have to do now, when you are trying to add two positive numbers, so add just, this is 1 1 1 is 1 0, 1 1 is 1 0, 1 1 is 1 0. Okay, 1 you are getting the carry. When you are trying to add two positive numbers, you are thinking that there is a carry generation, you have to add extra bits. If there are no bits also, you have to add extra number. What is Excess-3 of 0? 3. What is Excess-0 of 3? 0 3, right? This is the representation for 7 and 4, right? Now try to do this one. Okay, so just think about this. What is like, is 0001 exist first? No. When it is not existed, or in other terminology, if I say, if carry generated, what I said, Simply add plus 3. Okay, now if you add plus 3, what is going to happen? 0, 0, 1, 1, right? So we are going to get 1, 0, 1, 0, 1, 0, which is Excess-3 code. In our decimal system, in our BCD system, what is this value? 1, right? Are you going to get the 1 or not? Yes. Now try to think about this case. What is sum of triple one? 1, 1. What is sum of triple one? 1, 1, 1, 0, triple one, right? In 0, triple one, is there any carry generated? No. No carry generated. When no carry generated, what you need to get here? Again, you have to get 0, 0, 1, 0, 0 only. This is my requirement. Can I get 0, 1, 0, 0 from 0, triple one? Minus 3, right? You can simply subtract minus 3. 0, 0, 1, 1. Minus 3. Here I am trying to add plus 3. If you subtract minus 3 from 1, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 0. Are you getting the result or not? So this is what 1 in Excess-3 system. So 1, 1, 1, 1. Are you getting the data or not? Right? This is what you have to follow. See. So try to take one more example. So take out 0, 9 and 0, 9. See, you have to write like 9 and 9. As generally I will get the carry. I am directly adding 0 and 0. Right? What is the Excess-3 code for 0? 0, 0, 1, 1. For 9, 9, 3, 12. That is 8, 4, 12, 0, 0. And the same thing, right? 0, 0, 1, 1, 1, 1, 0, 0. See, first analyze what is the result you need to have. 18 means that at the final, what you have to have? 0, 1, 0, 0 and 8, 0, 1, 1. So this is the result I have to get, right? If you are going to follow our procedure, if you are going to get this answer, our procedure is perfectly correct. See, this is 0, 0, 1, 0. This is 1, 1. Okay. Right? Means that when there is a carry generation, you have to add plus 3. When no carry generated, you have to add minus 3. Right? So carry generate as carry generated, you have to add plus 3. 0, 0, 1, 1. When you add 0, 0, 1, you got 1, 0, 1 or not? Which is equal. Right? Now take out this case. This is 1, 1. This is 1, 1, 1, 0. No carry generated. So you have to subtract 0, 1, 0, 0. These two cases. Sorry. So are you going to get the result or not? Right? Take out any case where you need to have the borrows, like adding zeros. 4 and 3. Let me take two numbers, 4 and 3. What is the Excess-3 of 4? 0, 1, 1. Excess-3 of 6. Sorry, Excess-3 of 3. Right? 1, 1, 0, 1, 1, 0. 4 plus 3 is 7. In Excess-3 system, is there any carry? When there is no carry, what you have to do? Again, you have to subtract 3, right? 0, 0, 1, 1. You are going to get 0. From 0, you are going. If you are going to remove 1, minus 1, or 1, 1, 1, right? 1, 0, 0, 0, 0, 1. What I did here? See, from 0, if you remove 1, you will get 1. I am going to get the borrow from other side. But see, what is the meaning of 1, 0? 1, 0 in decimal system, 2. 1 in decimal system, 1. 2 minus 1 is 1. 1 in binary system. 1. Okay, so you have to take binary system. See, I have taken, see, borrow. So 1 0 I got. This is 1. These are in binary system. I am trying to convert into decimal system because it is our understandability. 1 0 in decimal system is 2. 1 in decimal system is 1. 2 minus 1 is 1, which is in decimal system again. I need to convert it into binary system. What is 1 in binary system? 1 base 2. So that's why I have written here 1. 1 0 1 0. Okay. Is this procedure is correct or not? Yes, like this you have to follow the approaches. So in Excess-3 addition system, when carry is generated, you have to add plus 3. When carry is not generated, you have to subtract with minus 3. So it's almost 4:15. Okay. So in the next class, we'll see the next concept. Okay, we'll stop here. So if you have any doubts, you can ask.